Recording now, I think. I hope. It's okay if you remind me to do so. Yeah, I'm recording now. The set from navigation, the HiPAP, the Kongsberg in combination are giving us a vertical position. However, this is not extremely accurate. Certainly the DigiQuartz depth value is a lot more accurate. So what we can do is we can disable this one here, use set from navigation, and the alternative is then to use another instrument. And this other instrument, of course, is the DigiQuartz depth. So use the browse button to the right here and then choose, if I can find it, DigiQuartz depth, this instrument. And then the channel number is 0. There are only two possibilities, 0 and 1, and that's, well, a little bit in conflict with what we're calling it here. They are called channel 1 and channel 2, but up here they are called channel index 0 or channel index 1. So channel 1 in the data acquisition is equal to channel number 0 in this setting here. Yeah. That's something you have to accept, I'm afraid. But anyway, this is an important setting, actually. If you have a DigiQuartz depth or any pressure sensor that you're using as we call it a Bathy sensor, then that should be actually used. You should overrule the default setting, which is the USBL height or depth value set from navigation. Now we can continue with the next one here, the Seabird 49 CTD. A little bit like the Atlas TSO20, this is something that I am including. Well, for the sake of the training, we're going to use the Seabird intensively at a later stage when we start using the Datamon tool. Yeah, I'm sure you guys have done the Datamon e-learning, so you must be looking forward to this. Anyway, the Seabird is a little bit special. It is a data acquisition instrument, and if you look to the right here, you can see that it has 3 channels. It's a CTD, so therefore the channel 1 is the conductivity, channel 2 is the temperature, and channel 3 is the depth. CTD, conductivity, temperature, depth. However, if you look up here under info, you can see that there's more information. We've got temperature, of course. We got conductivity, and these two are used directly. We've got pressure. Pressure is used to calculate the depth and to populate channel number 3. And in addition, we have salinity and sound velocity. And I want to show you how you can, if you interface an instrument that has quite a lot of information, then you can actually make that available. Also, that additional information, you can make that available to Navipack either directly, or you can use it to calculate some parameters that you can then interface into Navipack. But enough about that now. It's we're just using the default settings here, apart from the offsets and the IO mode that was set to simulate it. Yeah. Data acquisition. Now we've got 3 transponders on the RV. 2 of them are related to the Kongsberg, that's the port and starboard. I just want you to check and make sure that you have remembered to enter the TP code. That's extremely important. Otherwise, we can't use it. For port, transponder X-1. For starboard, transponder X1 and TP code 2. And for the center one that's related to the sonodyne, TP code 3, and the Y offset is -1. Maybe I should mention that the way we define offsets on the transponders are, of course, the same as we define location of, for instance, surface navigation, GPS antennas from the CRP of the object to the transponder in this case. Now that we have transponders, then we can have a look at the RV object again, and then say, okay, I actually want to use the weighting by standard deviation. Remember, we were setting up here saying that we can weight the position. Down here, we're saying we want to do this for the RV. You could actually be in a situation where you have several secondary objects. You don't want to weight all of them. But in this case, we want to weight the position based on the standard deviation that we have on the different transponders. The next instrument, the Teledyne RDI DVL. Well, it's a complex name. RDI was the name of the company, RD Instruments, bought by Teledyne, and DVL means Doppler velocity log. Principle of a Doppler log is that it sends out bursts of sound vertically in 4 directions. It's the 4 transducers are tilted slightly, but they're still sending the bursts out vertically or close to vertical in 4 directions: forward, backward, left, and right. And then it is measuring the Doppler shift, that is the change of frequency of the returning signal, or rather the returning signals in the 4 directions. And based on that, it can calculate the speed in these 4 directions. And then again, based on that, it can calculate the speed and direction of the object in question that is carrying the DVL. Speed is actually in 3 axes. And then, of course, we have 4 pieces of information. So we have redundant information, and that part is called the error velocity. And that's basically a standard deviation of what we can do here or what we can determine. The Doppler log has a very high relative accuracy, a lot better than the USBL system. But it doesn't know where in the world it is. It just knows that I'm moving with this speed, and now I'm moving that speed and in that direction, etc. But the point is that if you're combining your USBL system, which is noisy, with, well, basically it's noisy, but it knows where it is. If you combine that with a DVL that is not noisy, but doesn't know where it is, then you get a combined position that, well, knows where it is and is not noisy. At least that's the ideal scenario. This combination we call a Kalman position. It's not just using the Doppler log and the DVL, it's also using gyro and motion information, whatever is available, to calculate the best fit Kalman position. If we go to the RV again object, you can see this is what we have defined here. Use Kalman. Anyway, back to Teledyne RDI DVL. Make sure that you're using the RDI PD6. This is the binary format. There's a lot of different formats here, but RDI PD6 is the binary format that we want to use. That's what the simulator does anyway. Something about gyro, roll, pitch mount angles. Quite often we see that clients are requiring that you are doing a DVL calibration. Basically, that is a gyro mount angle determination. What we can say is that Navipack doesn't require that, because Navipack will simply determine this value, this gyro mount angle, based on a couple of updates of the Kongsberg HiPAP or Sonodyne USBL system and the Teledyne in combination, and constantly calculating this best fit orientation of the DVL data. Quite often you have to do it anyway because the client doesn't believe it. So, and that's fine. You can do that. This is also one of the things we'll be talking about in Navi Edit, because this is where I would recommend that you do it. If we go to the data output, I've asked for 5 outputs. That's quite a lot, as a matter of fact. Here, 5 different outputs. We're using the same driver throughout. Position exp to Naviscan, and that is simply because that is the most sophisticated, the one that gives us most information to send to Naviscan. I've talked about that we want to make raw data available for the post-processing guys. Raw data in this context, of course, are the ones that are related directly to the transponders. This one here, port to Naviscan, starboard to Naviscan, center to Naviscan. They can be used in, they will be logged in Naviscan, but they can be used in NaviEdit subsequently to improve your position. To make a recalculation of the weighting in NaviEdit, and then to create a Kalman position also in NaviEdit, where you combine the best fit transponder combination with the Doppler log information. I've listed these in an awkward sequence. Kalman to NS, that's the Kalman position. And up here we have RV to NS. That is the combined USBL position. Of course, the Kalman is a combined best fit Kalman position. Online, Naviscan and Navipack, for that matter, would like to use the Kalman position because that's the best. It's assumed to be the best position. So that should actually be the first in line. This should be the top priority. And the RV should be the second priority, and the others are just there for post-processing purposes. The funny thing is, I put this one at the bottom here, but I don't know why it changed the sequence. yesterday. But anyway, Kalman to NS should be the first one, so I'll move it up here, and now we've got the sequence that makes sense from an online perspective. Kalman to NS, RV to NS, these are or can be used online. Of course, it'll be the Kalman that will be used, and the RV to NS is just a fallback. And then we got the 3 transponders here that are used for post-processing. Yeah, there's not much to say except that, of course, the source should be matching the name RV to NS, that's the CRP. And then port, starboard, and center with different IP addresses. So if you're wondering at this stage, because it becomes a bit much to remember all these IP addresses and COM port numbers, etc. How do we get an overview of it? We can do that by choosing this one up here, select instrument by port. That's the rightmost icon here. That will give you a list of instruments with the instrument names. These are the names that we have given them. Which vehicle are they on? And the mode. Simulated, many of them on. All the ones that we're creating in Navipack are outputting from Navipack to Naviscan are on. And of course, then we have this special one up here, ZDA time plus PPS, that we put into off mode because we don't have a COM port one. And we don't have a ZDA time plus PPS. I don't have that for sure. All the rest are being simulated. Serial data simulated. And if you look here, you can see that it's listed a little bit awkward. It starts with COM1 and then COM10. But that's because it's only looking at the first digit, or it is looking at the first digit first and then the second digit after that. So CPath, shared, gyro, and motion on COM10. It was on 11, CBER on 12, double log on 13, primary GPS on 2, secondary on 3. We've got the octant gyro and motion on COM4. I got the Anschutz on 5, the TSS motion on 6, Atlas DESO data acquisition on 7, Kongsberg USBL, Sonadyne USBL on 8 and 9. It's important that we're not using the same COM port number twice, except for the gyro motion CPath and the gyro motion octants. Same for the UDP IP 5000, 5005, 10, 15, 20, 25. So we can cancel now here, close the window, and we should be in business. I'd like us to go online. I haven't even tried to go online with this configuration. I suggested to you that you did it, so then I didn't do it myself. But I opened the project setting just to have a look at Valve Start, Health Display, and online. There are some other windows that we should open, but not just now. Let's start. Enter online. And then you see that, first of all, I get a manual start. Secondly, you can see that I've got all these, both surface navigation instruments, but I also got all three transponders here, and I'm choosing all three. Probably a little bit unusual to use three transponders on an RV, but we'll do it. And then see how everything looks. I got my display here. And now you can see I got a tremendous amount of vehicles. I got the vessel that we saw yesterday. I disabled the view of the filtered vessel position. I got my USPL1 reference. That's the hydrophone position of the Kongsberg. I don't want to see that. I don't want to see USPL2 reference either. That's the position related to the Sonodyne hydrophone. I want to see TP1, TP2. I want to see the RV. I want to see RV Kelman. I want to see TP3, but I don't want to see priority 2. That is the GPS position based on the secondary GPS. That's certainly not relevant in the moment. You can see all these transponders, they are in strange locations. Well, they're certainly not coming together as one position on the RV. So how can we handle that? How can we fix that in, I go into 2D, how can we fix that in Navipack? You have to open now the Navipack simulator and then choose here, simulate, edit, simulate ini file. The simulate ini file is helping you to control the locations of the different transducers. It's opening in a notepad file like this. Now, you can see that there's quite a lot of information here. You don't, I'm not going to remove this. This is something that I was using for my e-learning, my TMS e-learning. So that's really not relevant to you. Whatever I have down here is not relevant to you. What is relevant to you is the one that we have up here, TP1. With this line here, I am telling Navipack to simulate TP1 10 meters to the starboard, 20 meters ahead, and 103 meters down relative to the CRP of the vessel. 3.4 is noise, just to make it realistic. USPL systems always have noise. I'll just put in 1 here. And then I will actually copy paste this line here, like this. So now I have 3 lines, and then basically say, okay, I have TP1, TP2, and TP3. And of course, please remember that this is only for simulation, this part. Now, you remember the offsets that we were using? If we say that TP1 has X offset of 10, then Y has offset, X offset of 12. Notice that TP1 X value was -1, TP2 X offset was +1, so the difference is 2. So if I do like this, then they will match approximately. The Y value is the same, and the depth is also approximately the same. For 3, the X value was 0, and that's 11 here. And the Y value was then -1. On the transponder, that is -20, -1, that is 19, like this. So this will give us, and that's why we were using these relatively simple offsets. So pay attention to what happens when I say File, Save, then the transponders will come together here. Move in, they are somewhere around here. And then what is all this? Well, we can start by associating a 3D model to the RV. That could be the RV here. So now I got the RV here. I could also do the same for the RV Kalman. So we can see if there is can use the same 3ds figure for this. So they're not identical position, and that's good because there's noise on my USBL systems. So I'm looking at it in 2D, as you can see. If I look at it in 3D, it's actually a little bit different story. They are down here. To make this easier to go to, I can always say right click on the RV and say move to, then it moves to the RV. And the cam is also there. But if try to notice the transponders are in the air here. And that's simply because the RV is not using the vertical component of the transponders, because they're up here. The RV is using the DigiQuartz information. It's a little bit difficult to see the DigiQuartz yet, but if you open the raw data window, see if I can remember what is. Was it this one? No. Yeah, this is the DigiQuartz on port 11. I'm doing it in the raw data window. And in the raw data window, we are selecting by port. Notice that if I'm not using the raw data window, then I close it. This is extremely important because it's using many resources from the system. So you should never have two windows open, two raw data windows open at the same time. And you should never have the raw data window opened together with the next window that I'm going to show you, the instrument SPI window. In many ways, instrument SPI window is the same as the raw data window. There are two major differences. The one is that you do not select by port here, you select by instrument. So that's, of course, a little bit easier to see what it is. And the second part is that you don't see the interpretation here. Well, you can say third part is that you can see both incoming and outgoing data from here. In the raw data window, you can only see what comes into Navipack. You can capture data. What you can say is that this is 196.45 psi or something like that. You can capture if you want to log to a raw ASCII file. Press capture and then choose go to our project location. Yeah, we can put it on the logging, I think. And then just put it in the root here and then say capture. Sometimes these data is coming in with a very high frequency. It's totally impossible to see what's going on. And then you can capture and then you can nice and quietly have a look at what was actually being logged. So if you press end capture, then it will automatically open the captured file in Notepad, as you can see. But anyway, this is the reason why we got the transponders up here and we got the RV down here. And that's of course because the height value of the transponders were a little bit out. So let's try to use, oh, not that one, it doesn't matter, but instead. I save this, then you will see that the transponders will go down to the RV. And of course, this is just simulation stuff. It's basically just to make our simulation data look realistic. Yeah, it's still a little bit off, but that doesn't matter. If we look at it in 2D, we can see that they're actually matching quite good. Especially if we're not looking at the Kalman. We got the TP1 here, TP3 here, and TP2 here, and that's totally in compliance with what we're expecting, especially if we say that this is our local coordinate system and this is Y0. But they're not going to match 100% because there is noise associated with the data. Let's have a look at how we can see the quality of these. You saw, remember yesterday, we were using the position monitor to determine the quality of what we were receiving from the GPS instruments in a combined solution. I didn't mention that yesterday, but you can actually see the standard deviation of the position here. And of course, that's based on the residuals that we have. We can do the same for the USBL systems. You can open this window here. That's called the object monitor. You also open it from here. View object monitor. This is a very useful window. You can see at the moment, all my objects are being visualized here in black. If, for instance, the RV is not coming in, then it will be shown in red. So basically, you see the positions, speed made good, course made good, accuracy, if applicable. See, RV TP1 has an accuracy of 1.2. This is coming from the instrument, from the telegram. The TP3 has an accuracy of 1.77, also from the telegram, and the combined position has an accuracy of 0.4, something like that. It also jumps sometimes. But there are better ways of showing this. If you choose view here, then view combined vehicle 1, then you're actually looking at, try to compare. You can see that you can call these LOPs in 3 dimensions. Here we have LOPs in 2 dimensions. LOPs in 3 dimensions, we've got the accuracy from the instrument here as well. And here we've got the accuracy of the TP3. Navipack will calculate the weight. Basically, the weight is calculated the same way we're doing it up here, relative to the inverse of the square of the standard deviation that we have here. So basically, it will take the lowest standard deviation and give it the weight 1. This is just a relative value, and then calculate the other standard deviations relative to that. So basically, you can say that this one is given the weight 1, and this one is given the weight 1.77. That is basically, well, basically 1.2 squared divided by 1.77 squared. That's this value here. Then it's making a combined solution because they're not matching 100%. And that's, we see the residuals down here. They are reasonably small. And the standard deviation that we can calculate are here. This is really good, actually. But you can also see that if I change my noise, I don't know how realistic that is, but then these will match a lot better, and my standard deviation becomes smaller. And if I set the noise to 0, they should be very close to 100% match. Yeah, there's some rounding stuff, but we're getting very close. And that, of course, is not realistic. So I'll give them 1 and 1 and 0.9. This. And then we've got noise immediately, as you can see. But this is simulation only, this part of it. But the calculation, of course, is not related to simulation. It's taking the values as they're coming in from the simulator and making a combined solution using the weighting. This is the weighting based on the accuracy from the telegram. I can just see if I can find this. That was not that one there. See, there is, that's this value here in the string. That's the sonodyne. You can even see it down here. 1.77, that's used directly. And for COM8, we've got 1.2. Yeah. This is something that was done introduced not long ago, a year and a half ago. So this is brand new, actually. And whatever you're choosing here online can be modified in Naviedit, and that means that if you have a transducer in the water that is not used in the solution, it will still be logged in Navipack, and that means that you can bring it into Naviedit. But that's just explained in the Naviedit e-learning module how that is done. That's quite good, actually. Another thing that's good is that this is a configuration setting. This choice that we have done, as you can see here, this is a configuration setting, weighted position, and this one as well, and also the fact that we're using it for the RV is a configuration setting. So you can do a manual start, and these settings will prevail, as opposed to what we saw yesterday with the surface navigation, which is a online setting that will change if you do a manual start. So that's quite useful. As you can also see, it's useful to have this possibility to show in the object monitor. You can just open another instance of the object monitor if you want to see this part. So basically, you can have these opened simultaneously without any problems. I'd like to talk a little bit about no, let's before we're here, we might as well sail a little bit. Remember yesterday we were sailing using the simulator, use runline, and then we were using this one here, aarhustransit.rlx. Let's see the RV. You can see the RV come, and it takes a little while before it decides what to do. That basically means it takes a little while before it settles in. Let's talk a little bit about the health display. These are the default windows that are always open. That is the map view window here in the middle. I got the project tree and the properties to the left. They are very important windows that I personally never close. Let me try to choose prioritize positioning again so that I get my priority 2 here and not in red. I don't like red here. These windows are always opened, at least when I'm using the health display. The project tree contains information about the current project, as I explained to you yesterday. And the first line in the project tree is the name, or gives us the name of the project in question. The display is always helping you. If you right-click in this window, then you can do a lot of different things. One is to open containing folder. Let's try to do that. This is a shortcut to the containing folder. Opening here. Remember yesterday, this is our project, health and display virtual on-off.hmp. And this is then basically a folder. Virtual on-off HMP. And then inside, and that's the case for all health and display project, there's a file called project.hmp. They're always called project.hmp. And this is the XML file, the project file that is pointing towards a folder with the same name. Inside that folder, there are different folders. The toppings folder contains the contents of the project at the moment. not a lot, as a matter of fact. The only thing is the aarhustransit.ilx, which was the one that we loaded originally, and it's being converted into an ILXP file inside the HelSense display. And there are some other settings here, geology settings, 3D models that we have loaded, RV and TOG. And they are there because if you move the project to another location, then they should also always be there. Palettes, well, that's basically default palettes that we might use if we are going to create an online DTM, for instance. But at the moment, we don't have that much here. Master project file. This is basically the project file that is copied in here in the master folder. And then we have something called distribution copy, which in many ways is the same as we have here, but this particular folder is used to copy to remote HelSense displays. If you have a remote HelSense display, if another computer is linking to this computer and say, I want to be remote to you, then Navipack will simply copy this distribution copy project to the remote. This is something that we can have a look at later on. I need to have another computer up and running for that to work. I already have that, but I just need to start it up.
Excuse me, Hans.
Yeah.
Could you please show me again? How did you open this folder? Actually, I missed it. Like from which option in the HelSense display?
Yeah. Project tree. Can you see my cursor?
Yes.
Right click.
Oh, okay.
You see all these? You can open anything you want to do from here. This is how that's what display is helping you. It's even a shortcut to the topping folder, but all of this is very useful, as a matter of fact, because you always know where it is. Otherwise, you have to browse and try to find it, but that's not necessary here. Now, let's continue. We've got, at the moment, there's one here called run lines. And notice that the run line is shown in bold, and that is simply because we can have more run lines in a project, but only one can be the active run line. The active is shown in bold. The same applies in other contexts. If you have more DTMs, only one can be the active, and that will then be shown in bold under surveys, because this is where we have the DTMs visualized. Now let's go to the Navipack online connection. We are distribution master, and we have a series of vehicles because we are connected to Navipack on our own PC, as you can see here, 127001. Here I got all my objects, the vessel, and as you can see here, there's quite a lot of information that I want to that I can use here. Easiest is, of course, say I don't want to see it. I want to see it. But what I would like to do now is to make a track plot of the RV and the RV Kelman, try to compare them and see if there really is an improvement by using the Doppler log. So select RV and then go down here and choose, let me see if I can find it, track, true. It's a little bit difficult to see with this color, but it's actually already there. I want to use red for this. Now we can see it. Track length, maybe I want to set that to 30 minutes. yeah, basically, this is fine. I did the same for the RV Kalman object. Again, I try to find the track down here, track property, change that to true. And then I would give it a blue color because, well, we're using blue for Kalman in other contexts. So let's do it here as well. 30 minutes like this. Now, if you want to pan, then you can keep the mouse wheel down and move the mouse or the cursor. But it's quite clear to see, well, this I know this is simulated data, but you can say the combination of the two is realistic. That is, of the USBL and the Doppler log. So that gives us this Kalman line. As you can see, that's quite a reasonably straight line. And that's the whole purpose, of course, of having a Doppler log. Yeah. There are some other views that we can have a look at. We've got, you can see all these toolbars up here. May not have them. Let's try to see what we can do in terms of toolbars. You can see there's under view toolbars, there is quite a lot of possibilities. Connection toolbar, that's this one here where we are connecting to Navipack. You saw that yesterday. We've got the file toolbar. Of course, that's this one here. We've got view toolbar. That's this one here, 3D, 2D, S. We've got create toolbar. That's this one here where we can create run lines, waypoints, digitized lines. DTM toolbar. We'll keep it. It's this one here where we are able to, and well, basically these here, where we're able to show the DTM in different ways. We don't have it right now, but we will be having it later on. Cleaning toolbar has not been enabled, and it's not relevant in this context. Camera toolbar, not relevant. KP toolbar, not really relevant. Follow toolbar is very important. And I suggest that you just do the same or use the same settings that I have used here. This is the follow toolbar. The icon to the left allows you to click on it and choose RV. If you do so, then the RV will be kept at the center of the view. You can see this one became active, and that is basically at the moment using north up follow mode. Good news here is that even though you're using north up follow mode, you can still rotate it and it still stays there like this. You can have your own orientation. See, if you move it down here in this corner, it still stays where it should be. So that's quite convenient. run line up follow mode. We don't have selected a run line right now, as a matter of fact, even though it looks like we have. We haven't. We're going to log data in a little while. As a preparation for that, I would like you to open one of the views, a very important view. This is called a vehicle control view. Mine opened over here. This is the vehicle control view, and it is used to, well, basically control objects relative to run lines or waypoints to start logging, for instance. So let's, I normally I dock my windows. This is very important that you learn to dock windows. You can grab the windows by the caption here. The minute you then start moving it around, you can see these small squares here. If I move my cursor here, and you can see that the light blue outline will show where my vehicle control will be placed if I put it here. I obviously don't want to put it here. It takes up too much space, so I can move it again. Now it's floating again, and then I can move it around. Where I want to put it is actually over here, see? The minute I move it over to this column here, I get a possibility of putting it underneath, and that's what I want to. This is where I want to have it. But before we do that, maybe it's better to just have a look at the possibilities. I got all the objects. By default, I have all the objects listed here. I don't want all these objects because many of them I can't use for what I have here. You can see the transponders are not listed, but the rest is. So this is a filter. Click on that and then choose which ones you want to see. I don't want these. Don't want the filter vessel position. But I want the RV camera and the vessel like this. Now when you see these, I got a, let's pretend I want to, I want the RV to follow the run line. I want to help the RV pilots as much as possible. I can do that by linking the RV Kelvin to a run line. Press the browse button and you can see that there is only one run line in the project at the moment. That's the one that we loaded yesterday, Aarhus Transit. So now, here I am. I am navigating, as you can see, relative to Aarhus Transit. If I select this line, then you can see all these icons that we have up here become active. One very important one is this one here. Show left-right indicator. There you go. Now I have a left-right indicator of the RV relative to the run line. You can even see this dotted line, which is basically showing the perpendicular distance between the RV and the run line, and that is actually this value that we have here. I can also open a a data view. It's really valuable to have these data views. What you can see is that Navipack is suggesting to you the contents of this data view. I think I want to place the vehicle control over here now. RV Kelman, and a lot of information here related to this particular run line. If you look at the views to the left here, headline views, or the main node views in the project tree, you can see that now I have 3 views: the map view, the left-right indicator, and the RV Kelman. If I explode the RV Kelman, then you can see the contents here. These are the contents that I can remove or modify. I can also add to it. Now let's try to right-click on RV Kelman and choose add, remove live data. So what is live data? In the context of the Helmsman's display, live data is data that's being calculated by Navipack and that is available for different purposes, visualizations, etc. In this context, you can see that I have 229 sets of raw data. This is actually quite a limited number, and that's because we only have a simple configuration yet. Basically, you can see that there is already items that have been enabled. This will, of course, also allow us to disable these items. Let's see what it is that I would like to see. First of all, I don't need to see I'd like to see the heading of the next segment, actually. And I think also that the bottom here, runline navigation and runline name, well, it goes without saying that this is runline navigation. Or runline name, I don't want to see that. But I would like to see next segment. Yeah, there's not that much to see here. Next segment heading, that's great. Segment counter, yeah. Would be nice to be able to show the next, well, segment heading. See, now I got crazy. That can never be true. Next segment heading and segment heading, it can't be the same. That's a little bit awkward. It is actually. Why doesn't it give me the next segment heading? I think I know why. That's because the next segment is actually a circle, and then it will constantly be modified slightly. But anyway, it's also possible to remove from here RV Kelman. I can remove that from the list, and then that's not part of it anymore. But as you can see, there are so many possibilities here, and this is early days still. So basically, it gives us a tremendous amount of possibility. I will save my configuration now, and then I will prepare to start logging. I do that by enabling the log data window here, project settings again. In the configuration, I go to warm start and I enable log data. Under advanced, there's also something here. Yeah, that's not relevant to us. Yeah, there is one here that is one setting that could be interesting. When we're logging our data, the first part, we're always logging a header. So the first part is a header that contains information about the current settings. By default, Navipack, if you change settings, that could be, for instance, if you say, okay, I don't want to use GPS2 anymore, then that should, of course, be reflected in the header. And Navipack handles that by simply creating a new file from scratch, closing the old one, opening a new with a new header. Some companies dislike this and they say, okay, we don't want that. Don't auto start stop because of online changes. But be aware that I think 90% of the users will always use this default setting. But anyway, log data must be enabled. I want to restart now to make the changes take effect, and I have saved my health display. And now I restart. Navipack, or you can say re-enter online. So here is the log data window. Not responding, that's the first time. Uh-oh. Restart. Guys, I don't know what caused this. That was a little bit scary, I must say. I think that the mistake I made was that, and I always do that, but I didn't do it this time. During mobilization, I always force a manual start. I think that's probably what caused it. I forgot to do that. I'd like to think that that's what caused it. Anyway, primary GPS, secondary, all transponders. Yeah, here's the log data window now. And we can log data now because the log data window is opened. But of course, we need to set it up so that it is logged in accordance with what we want. The location is wrong, by the way, at the moment. So let's start by saying file setup logging. These are the configuration dialog for the logging in Navipack. Remember yesterday we were talking about the format. In Navipack, we're logging ASCII files. We have three different formats. We have the general format. We have the navigated format. That's also sometimes called the survey format. And then we have the custom format. As a matter of principle, I will always log in all three formats. You may notice that I'm always saying I want everything. I want to log in all formats, etc. And that is true. I'm not being careful, but I don't see any reason why I should limit myself by not logging a format. It doesn't take up too much space on my hard drive, and it doesn't take resources from the system. So why not do it? You can say that the navigated format is the format I will use for post-processing. The general format is a format that contains everything, including all raw sensor data. The survey format also contains everything, but in some cases, the raw sensor formats are interpreted slightly by NaviPack. And the custom format, as the name indicates, is a custom defined format. The general format is used primarily for debugging, because it does contain some extra information. It could, for instance, be you want to know something about whether your ZDA plus PPS is working properly. You can only actually see that in the general format. Quite often you don't want to see it yourselves, but either support might ask you to send or to supply the general format if you address the support, because then they can use it for debugging. The navigated format, of course, is designed to be used in navigated, so the navigated NaviPack interpreter understands this format. And the custom format, as I said, this is up to you to decide how it should look. I'm normally always logging these three formats in the same folder, so let's try to say browse and go to the log folder in the project that I have supplied to you. This one here, logging, NP for NaviPack. NS, of course, is prepared for Naviscan, but NP, and just stay open to that. And then you can copy paste this to others like this. So everything will be logged in the same main folder. We will be creating a subfolder though. I'm just using default settings, but as you can see, you can choose whatever default settings you want to use, or whatever subfolder settings you want to use. You can also create a prefix if you want to for the name of the file, but I'm basically always using the NaviPack naming convention. But of course, there could be reasons why you don't want to use that. Recording mode, all updates. I always do that because, I mean, the alternative on events, that is only something you do if you're not going to use this for anything in post-processing. So always all updates. Settings down here have been grayed out because in the old days you need to, or you were able to define some of these settings, but that's not the case anymore. So I'm not going to talk about it. You've also done the log data e-learning module. Anyway, displays warnings, makes good sense. Log file size, when I'm doing NaviPack and Naviscan in combination, I'm always using something like 15 to 20 minutes. And I use the same setting in Naviscan. So that we're starting and ending log files at the same time. Yeah, the bottom part here is only to display for display purposes, and displaying everything like this. Yeah, primary logging like this. It is possible also to define a custom logging format, which is something I'm not going to go into details with. You can say that you have to be a little bit careful with it because the available list here is being populated from the online database that you, where's my, there it is. Let me show you what I'm referring to. This one here, the online database. That online database is changed whenever you modify your configuration. So you have to be a little bit careful with it. And that means that you might lose some of the information that you think you have here. So basically, if you want to use it and it's essential to you, then go and check that the items are still there. But let's see, time. I just want to show the position of the vessel. Position of the vessel here. And octane gyro motion as well. And then perhaps also let's just say this is okay. I'm simply just logging the position of the vessel. Some people are using this also to, for instance, when you are launching the ROV, then you could be logging a CTD profile through the water column, and that could also be used here. Positions, include the height, can also include KP, distance along line in meters, distance offline in meters, and then your date and time, fixed format or a custom format. If you press the help, then you will see how everything should be interpreted here. We'll take this hours, minutes, seconds, day, month, year, and year will be with 4 digits, 2021. Go to the general tab, and then you can enable these settings here. Save header, include time, version, and file name, and runline info. That's always nice to have all this information. And then generate header from selected items to see what's actually the header looks like. You don't have to press this to actually create a header. This is just to visualize the header here. So I will accept this, save the settings, and then I will move it to the side here temporarily, and I will take my simulator, choose a run line, AarhusTransit.ilx, and then I'll start sailing along. they're looking a little bit strange here initially, but that's because, I mean, the vessel has changed its orientation. And of course, with the position of the, let me have a look. Yeah, let's remember it. Yeah. Now, down here, the RV Kalman object is selected in the vehicle control window. And RV Kalman is associated with Aarhus Transit. So now I can start logging. Start line, it says. If you look at the bottom left icon here, start line. I start line, and a few things are happening. The line becomes green, indicating that we're logging data, or we're not logging data, but we have started survey on this line. In the top left corner here, you have these 3 tick marks. First one says connection status. That was green before as well, or already. Second one, show NavPack status. That means we don't have any important warnings in NaviPack. The last one is just been enabled NaviPack logging status. We are logging data in NaviPack. That's what this means. You have the same at the bottom right here, and that's simply there because sometimes you don't have this toolbar opened. So basically, that's the reason. And now, equally important is the fact that we can see here that we're logging data. That's quite evident. Blue background indicating that we're logging data now.
Excuse me, Lars.
Yeah.
I have a problem, like there was a warning pop-up like custom format has no item selected, no logging will take place, and it is giving a like.
But that's because you haven't defined any custom logging. You didn't do that.
I've like in the custom logging format.
No, you haven't. I have to say you haven't. Let me try to show you. I will stop logging now. Here, first of all, you have said, I want to log custom format. That's step number 1. The second step, you have not got anything over here.
Oh, yes. I got it. I didn't select this. I missed this one. Okay,
Then you get that warning. But it will still log. It says no logging will take place, but it's just the custom logging that will not happen. The 2 survey file or navigated file and general logging will still take place. Now, my recommendation here, because you can start logging from this window, but my recommendation is always start logging from the log data window, because this is also the way that you are ensuring that you will be logging in Naviscan later on. So we're logging data now. There is actually a shortcut here, view custom log file, whereby we can open the current log file in Notepad, as you can see, with header information, I also included, I asked for run line information as well. We've got time, date, we've got easting and northing of the vessel, including the height. A little bit strange height, but never mind that. That's because we haven't defined any geodesy yet. So this ellipsoidal height. We've got, let me see, what is this? I should be able to see it. KP, distance along line, distance offline, gyro, roll, pitch, and heave. Awkward heave, constant of 0.8. That means that we're flying upwards, but that's just simulated data. It's a good thing to have a header, because otherwise it's a little bit difficult to see. But you can see that the KPs are growing. And that we have exactly the same number here. This is distance offline, and this is KP. This is in meters, this is in kilometers. So this is distance offline. Notice that this distance offline is actually the distance offline of the vessel to the same run line, which reminds me, it's sometimes the captain would also like to know whether he's on the line. We could have another line for him. Let's try to link the vessel. We don't have, only have one run line at the moment. I'm going a little bit fast now, I can see that. From the vehicle control again, browse on the vessel line here, and then choose Aarhus Transit. Select it, and now there's a left-right indicator here as well that I can dock like this. So now you see the vessel, how well it is following the line, and how well the RV is following the line. One of the things that you can do in the Helsense display, let's stop logging now. I'm not logging anymore. One of the things you can do is you can, on these run lines here, it is possible to or transit, you can create parallel lines. Let's create just two run lines, one to the left, one to the right, with a line spacing of 10 meters. Let's try to do that. See, now I have three run lines. And what I would like to have now is the RV element to be linked to this run line. The vessel still linked to that run line. So I can browse again and then choose +10. This is then the one that is 10 meters to starboard when we're looking at the run line from start of line towards end of line. And then you can see that this one swaps automatically. You can also see it here, run line navigation, RV element to 10 meters. That's what it's called. I could have given it another name, but that's not necessary. So now you have the vessel related to the original run line and the RV Kelvin related to the 10-meter wing line. But apart from that, it works in exactly the same way, the logging. Like this. So now we are ready to log data in Navipack. Let's have a look at, I'll save my health display. And then I want to go to my configuration, my Navipack configuration. One of the things that let's see if I can find it. This PowerPoint presentation here. I'm talking about the link between Navipack and Naviscan. You have seen that we have created the run line control. We're also sending positions to Naviscan, a lot of position to Naviscan. But then we've got this thing here called shared ports. I was talking about it yesterday. This is Navipack sending time-tagged relevant sensor data to Naviscan. And the relevant sensor data, of course, are the sensor data that is related to Naviscan. Navipack is, you can say, a multiple object software. Naviscan is a single object software. Naviscan can only handle one object, and that is the object that is carrying the multi-beam echo sounder or the laser scanner or the side scanner or whatever, but only one object. So we need to send data to Naviscan that is related to the RV object. So that is the one that will be carrying the multi-beam echo sounder when we come to that. So how do we do that? If you go to project settings here, and then Naviscan at the bottom, here we can enable port sharing. Now, there's a good explanation down here. Should Navipack export data from data inputs to Naviscan and thereby enable port sharing between the two programs without losing time tagging accuracy? This is applicable for serial COM and UDP inputs of GPS, gyro motion, etc., etc. Sharing can be used on the same PC or on remote PCs. That's good to know. So basically, destination 127001, they're executed on the same computer, so thereby the destination should be 127001. That's the first part. Second part, port ID 16,000. This is a fixed number that we are adding to the COM port number to achieve a UDP port number. So any, let's have a look, the C path, if I can remember. Of course I can't. CPath is arriving on COM10 in NaviPack. Consequently, because of this number, NaviPack will make it available to Naviscan on port 16,010. So it's adding 16,000 to the NaviPack COM port number. And that happens throughout. This is a suggested number. You can choose whatever number you want to. But we'll just leave it as it is right now. 16,000. We can limit ourselves. Say we only want to send RV sensor data to Naviscan. Or we can choose not to do that. And then we choose, in the latter case, object limited to none. But in our case, we will limit ourselves to the RV. We will only send the RV data out. Now, if Naviscan and NaviPack are executed on separate computers, then the IP address, of course, here is different from 127.0.0.1, but then we can actually include this one here as well, so that it's also available locally. So why should we want to do that? Yeah, well, basically, you can say this functionality can be used for a lot of different things apart from just sharing data between NaviPack and Naviscan. You will see that later on today, actually shortly. But for now, we'll just leave it as it is, like this. That's actually the only setting we need to apply. And once we've done that, we are ready to support Naviscan from NaviPack, because we've got all these three links here. Maybe a little bit difficult to understand what's going on now, but you will see it later on fully. Okay, guys, coffee break. Let's meet again at 1:15. I will temporarily stop logging or recording. I think I did. I'm not sure. Yeah, I'm stopping recording, and then please